Yeah, so my name is Dr. Tricia Stadnik. I am a university professor at the University of Calgary and a Canada Research Chair in hydrologic modeling. So my research looks at water supply, how water is stored on the landscape, and how it moves across different landscapes. Isotopes are really cool. When we talk about the periodic table, every element has a different mass associated with it. And the atomic mass that we see on the periodic table is just one mass, but we can have many different masses. So for hydrogen, we can have hydrogen 1 and hydrogen 2 with different amounts of a different mass associated with it. And then oxygen, we can have 16, 17, or 18. The isotopes that I was talking about are specifically isotopes of water. So when we talk about water isotopes, we're talking about tracing the flow path. So isotopes allow us to look at where the water has come from, its origin, and also what has happened to that water along its flow path from upstream to down. We use them to look at changes in precipitation that are being driven by climate change. So as the air gets warmer, then we have more rain that's held in those clouds or more snow, but it comes from different sources. We can have it come from the south and from what we call the Colorado Low. We can have it come from the west over top of the mountains along the Pineapple Express, and the polar vortex when it comes from the north. And so depending on where the rainfall comes from, it will actually have a different isotope signature. So if we have a gauge that's capturing the rainfall, and then we take an isotope sample of it, we can actually tell where it's come from and what ocean it originated in. And then when we talk about isotope sampling in the streamflow, it's kind of the same thing. Depending on where that water has gone after it fell as rain or snow, if it's come right from the headwaters of the Rocky Mountains, if it originated in the grasslands of the foothills, or if it's down more in the agricultural area where it's had a lot of evaporation, we can actually see that when we grab a sample of streamflow at any point in a river. But there's other elements on the periodic table that actually allow us to track sediments within a watershed. And this is powerful when we couple that with water isotopes, because we can actually see if the water's originated from a rocky groundwater system, or whether it's come from the surface Rocky Mountains falling as rain or snow, or whether it's come from the soils. And different soils will have different isotope signatures based on the sediments in them, and we can actually study the isotopes associated with those sediments to help better understand the flow paths as well. To understand the past and how our water has moved and been stored in our landscapes, and how it's currently moving and stored in our landscape, is very important for us to be able to understand how it might change if we change something like the air temperature. That's very important for us to understand the whole system and the system behavior, and the only way we can do that is by studying what's happened in the past.